Welcome back to episode 4 of Ultra Frontier Explorer with me, Dr. Jon Overton, on AlwaysAroundNet. Today we're going to be riding along with the New Horizons mission to fly by the dwarf planet Pluto. This is the very first time in history that a spacecraft has visited Pluto, which is known as the King of the Kuiper Belt, a mysterious icy region of innumerable unexplored worlds at the very edge of our solar system, far out beyond the asteroid belt, beyond the gas giants Jupiter and Saturn, beyond even the ice giants Uranus and Neptune. Pluto is very probably the largest world out in the Kuiper Belt and was the very first Kuiper Belt object to be discovered by the late Clyde Tombaugh, as late as 1930 in fact. A little bit of Clyde's ashes are being carried out to Pluto by an extraordinary little NASA spacecraft about the size of a grand piano, which was launched on its 4.83 billion kilometre journey to Pluto 9.5 years ago in January 2006, when the lightweight New Horizons spacecraft, only 478 kilos, which is about 1,000 pounds in mass, was placed atop an Atlas V rocket with a grand total of 5 solid rocket boosters strapped to it, and for the first time ever with an extra third stage. And so New Horizons became the fastest spacecraft at launch in history. This launch set New Horizons off at 59,000 kilometers per hour. Just look at it go.
3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond. Plus 15 seconds. Everything continues to look good as the Atlas V vehicle climbs away from Florida's east coast. The 5 solid rocket strap-on boosters are burning just fine, sending the New Horizons spacecraft on its way to the very edge of our solar system.
About a year later, in February 2007, New Horizons flew by the giant planet Jupiter in a gravitational slingshot path that added an extra 4 kilometers per second to its speed. That's an extra 14,000 kilometers per hour, which accelerated the probe to a total speed of 83,000 kilometers per hour and shaved about 5 years off the total journey time to reach Pluto. Now hang on a minute, I hear you say, what's a gravitational slingshot? And how does it work to add speed to our spacecraft? Good question. Well, a gravitational slingshot, or a gravity assist maneuver, means that our spacecraft steals some of a planet's enormous angular momentum as it shoots past the planet, first into and then out of the planet's gravity well. But because the planet is so much more massive than our spacecraft, the loss in orbital energy to the planet is totally insignificant. Enormous Jupiter, for example, lost only the equivalent orbital energy of taking 1 drop of water out of Earth's entire oceans. But what is an infinitesimally tiny loss in speed for Jupiter is a huge boost for New Horizons, because New Horizons is so incredibly tiny compared to Jupiter. A good analogy to help understand how this works is to imagine that New Horizons is a tennis ball. No, really, bear with me here. Being thrown by some kid at the Jupiter train. But really, don't throw things at trains, kids. It's really dangerous. Don't do it. Anyway, the kid throws the tennis ball at a speed of 30 miles per hour towards the train, which is approaching the platform at a speed of about 50 miles per hour. So the tennis ball hits the train at a net speed of 30 plus 50, which equals 80 miles per hour. And for a tiny fraction of a second, that momentum, or in other words, the kinetic energy, is stored in the stopped, squashed ball before it rebounds with that 80 mile per hour energy plus 50 mile per hour more from the train, which is still pushing it as it moves. So the New Horizons ball leaves the encounter with the train at a total of 130 mile per hour. The train is only slowed down an incredibly tiny bit because it is so massive compared to the ball. Gravity assists by planets like Jupiter on spacecraft like New Horizons work sort of like that, except instead of interacting mechanically, they never touch, and instead they interact through the gravitational pull on each other. Gravity assists, or slingshot maneuvers with planets, are so useful that they're used to add or sometimes subtract velocity from spacecraft on almost every interplanetary mission to date. But of course, what you really want to know is just how good are the photos of Pluto going to be? Well, we can get a good idea of that from looking at the photos that New Horizons took on the Jupiter flyby. Now, at its closest approach, New Horizons was still 2.3 million kilometers away from Jupiter, and yet it still took some truly incredible pictures, both of Jupiter itself, which is the most massive planet in the solar system, being 2.5 times the mass of all the other planets put together. That's 318 times Earth's mass, and it's 11 times the diameter of Earth. And also, New Horizons took a load of pictures of Jupiter's moons. Now, when I say Jupiter's moons, Jupiter has 67 moons, but most of them are this typical size we more normally think of for asteroids. But the 4 Galilean moons of Jupiter, Io, Europa, Ganymede and Callisto, are all comparable in size to Earth's own moon. And each of the 4 is an incredible, unique world in its own right. Honestly, each of which deserves its own episode, to be honest, but we're just going to have a quick look at them today through New Horizons' eyes. New Horizons captured the first close-ups of the Jupiter system since the Galileo spacecraft was deorbited into Jupiter's atmosphere back in 2003. We witnessed the rotation of Jupiter and its incredible cloud system, including the 350-year-old Great Red Spot, a vast storm of 400-mile-an-hour winds that is twice the size of Earth, and its much younger cousin, the Little Red Spot, which is still bigger than the whole of the Earth. New Horizons saw Jupiter's very faint ring system and watched the shadows of Jupiter's moons cross its face. The little spacecraft spotted a brand new volcano and witnessed an incredible 300-kilometer plus high eruption of lava from rocky sulfurous Io, which is a little bit bigger than Earth's moon, but is the single most volcanic object in the whole solar system, with more than 400 active volcanoes. It's about the same distance from Jupiter as our moon is from Earth, but it zips around Jupiter in just under 2 Earth days. Io is in orbital resonance with the moons Europa and Ganymede, which means that every time Io goes around Jupiter once, Europa goes around twice, and Ganymede orbits 4 times. So Jupiter, Io, Europa and Ganymede all tug at each other with their gravity as they orbit, and this creates tremendous tidal forces in these big moons, heating them up. Especially Io. It's this heat from the tidal flexing that powers Io's awesome volcanoes. Here's another shot where you can see them glowing in infrared light. Also, New Horizons watched icy Europa rise over Jupiter's vast shoulder. Now, Europa is a little smaller than our moon, but it's very different from our almost totally dry, barren moon. Europa is rich in water, and Europa's amazingly young icy crust bears no impact craters, but instead has a complex fracture pattern. And deep down under the ice, protected from the ferocious radioactivity of Jupiter's magnetosphere, which blasts the surface, Europa has an ocean of liquid water, estimated to be twice the volume of all the water in Earth's oceans. Again, it's the heat from tidal forces with Jupiter, Io and Ganymede that keep that water liquid. Sometimes geysers of water erupt from Europa into space, which is a form of cryovolcanism. This liquid water, which is probably in contact with a rocky core, make Europa's subsurface ocean the most likely other location in the solar system for life besides Earth. So much so, in fact, that when the Galileo spacecraft came to the end of its life and ran out of fuel, it was deliberately crashed into Jupiter in order to avoid contaminating Europa, possibly. Now, like Europa, Ganymede is an ice, water and rock world, but Ganymede is much bigger than Europa. At over 5,000 kilometers in diameter and more than 1.5 times the size of our own moon, Ganymede is bigger than the planet Mercury, although it's much lower in mass than the planet Mercury because it has so much water, whereas Mercury is very dry, rocky and has a lot of iron. Ganymede is the biggest moon in the solar system. It is thought also to have huge subsurface oceans, but due to the greater pressures inside Ganymede and the unique multiple different forms of water ice that occur at increasingly high pressures, these oceans are layered in a strange ice-water formation inside Ganymede, like an enormous sandwich or onion or possibly a Scotch egg. And finally, stately Callisto, a third ice and rock world only a little smaller than Ganymede, nearly 2 million kilometers out from Jupiter. Callisto is not in orbital resonance with the other moons, so it's not tidally heated and is probably not even differentiated inside. Callisto's surface is one of the oldest and most cratered in the entire solar system. Callisto actually lies outside Jupiter's radiation belts, and so it's the most likely place in the Jovian system for any future manned mission that might get out there. So as you can see, New Horizons is a very capable spacecraft indeed, sending us terrific data even when it was passing a couple of million kilometers away from Jupiter. It's been 8 long years since Jupiter, and now New Horizons has reached its main goal, the fantastic Pluto and Charon binary dwarf planet system in the Kuiper Belt. And as you can see, New Horizons has already sent back some fantastic pics and footage of these remote icy worlds from 4.5 light hours away. That's 4.8 billion kilometers distant. These photos are going to get even better as New Horizons dives to within a few thousand kilometers of Pluto's surface. Now, how close will New Horizons get? What are the risks it's taking? And just how good are those photos going to get? Tune in to episode 5 of Ultra Frontier Explorer to find out more.